Yes. So actually, guys, we started with a concept called as concurrent hash map. So we are going to look at about concurrent hash map and what is fail fast iteration, what is fail safe iterator. I'll explain about those two things. With that, we can able to conclude collections, and then we'll start with the threads concept. Actually, first I want to complete. I want to explain threads concept followed by the features of Java. It will start on Saturday. So, guys, in the today's session, what I want to talk is first I want to explain you. Okay, first I want to explain you about. Okay, first I want to explain about uh, concurrent hash map. Okay, we want to complete the sessions a bit fast today. So we want to discuss about concept of concurrent hash map. See, I'll explain you. So there is a class called as concurrent hash map. I told concurrent map, concurrent hash map. These things I have explained in the last class, right? We have discussed about concurrent map and concurrent hash map. So now we are going to look at about that. Okay. Okay. Concurrent hash map is the class we are going to discuss now. I told concurrent hash map is like hash map only, but there is a difference here. See what happens in concurrent hash map, I'll tell you. In concurrent hash map, for example, you have 16 buckets, right? Whether it is a map like hash map or linked hash map or concurrent hash map or tree map, anyone, by default, 16 buckets are created. So 16 buckets are divided into 16 locks. Okay. For example, I want to make hash map object as thread safe. This is, let's say, hash map object. Assume that this is what hash map object. Just I'm explaining it so that you'll understand about what is concurrent hash map. Okay. We have, for example, this is a hash map object. Okay, this is hash map object, guys. I can tell you that this is the one hash map object. Clear? Let's go ahead. I'll explain you. This is called hash map object. I told you already hash map object is not a thread safe object. If, for example, two threads are at a time changing the value of a particular key, then one thread, okay, while one thread is performing the update, other thread also will perform the update on the same key because it is not a thread safe object. It will allow multiple threads to perform the operation on this. How can I allow only one thread at a time is I have to lock this object. This is actually called as, we are making it as hash map as a synchronized object. Nothing but we are applying concept called synchronization, which is called locks. We can lock the object. We can make it a thread safe. But if you make hash map object as thread safe, only one thread can be allowed to access it. For example, if one thread, there is a thread called T1. Actually, T1 is trying to modify the first key. And T2's actual intention is T2 wants to modify the last key. Okay, both are actually not going to modify the value of the same key. They want to modify the values of the two different keys. But still, the second thread is not allowed. But still, the second thread is not allowed. Okay, it has to wait because this object is already locked and T1 is using this object. So T1 has a lock on this. So that's why only T1 is able to perform anything. T2 cannot do any operation. Another thread cannot do any other operation. This thread has to wait until the lock released by T1. If T1 releases the lock, T2 can enter and T2 can perform operation. So this concept is called as synchronization. I mean to say that we are locking this object. But what happens now? Entire object is locked actually. T2 is unnecessarily waiting. It is not actually, it should not wait actually, but still it's waiting. It is unnecessarily waiting. Correct? It is waiting unnecessarily. That's where performance wise, if I make this hash map object as thread safe, application performance got decreased. But if you take concurrent hash map, what happens? Let's see what happens in concurrent hash map. Okay, let's see what happens in concurrent hash map. What I'm saying is, no, this is okay. Now this is, for example, concurrent hash map. If this is concurrent hash map, each bucket has a lock. For example, this bucket has a lock. Like that, each bucket has a lock. Means what? Each bucket means, for example, by default, 16 buckets. They have 16 locks. 16 threads can perform operation at a time. Okay. See, for example, T1 wants to update something of this particular key. If T1 wants to update the value of this particular key, then only T1 will lock it. T1 will get the lock of this bucket. So T2 is not actually doing operation on the same key, it is performing on another key. So T1 and T2 both are reload at a time. Concurrently, they can modify this concurrent hash map object. Because both the threads are not working on same key, they are working on two different keys. Now question is what here, the concurrent hash map means it doesn't map, it doesn't lock the entire object, right? It doesn't lock the entire object. It will only lock the particular bucket. Each bucket has a lock. This is called bucket level lock. Not the entire object level lock, only bucket level lock. That will happen in concurrent hash map. So at a time, how many threads maximum are allowed? 16 threads. Because 16 locks, 16 buckets. If, for example, T2 is also trying to, if the second thread is also trying to perform same update operation on this, then only T2 has to wait. But for example, if T2 wants to modify the value of the second key, then T2 no need to wait now. That is why concurrent hash map will provide better performance when compared with the what I can say hash map object. Correct. That's why concurrent hash map can provide better performance when compared with the hash map object. You got my point, right? So I will write all these statements now. That's how concurrent hash map works. Concurrently, multiple threads are allowed to perform operation. Remaining all same to same. Just I'll give you some points on concurrent hash map. Maximum at a time, 16 threads can be allowed to make changes to the concurrent hash map object. Because 16 buckets, bucket level locks are there. 16 buckets, 16 locks. Suppose if two threads are trying to perform operation on update on the same key, then only one thread has to wait. Otherwise, it no need to wait. But in hash map object, we are locking the entire object. Now that's why even though thread 1 is performing update on another key, one key, T2 is trying to update on another key, but still T2 has to wait because of the entire object is locked. That's the difference between hash map and concurrent hash map. So concurrent hash map will provide better performance when compared with the hash map object. Okay, right? That's how concurrent hash map works. So you no need to make this entire object as a thread safe. I mean to say, you no need to lock the entire object because they implicitly contain bucket level locking, which we can say that concurrent hash map is a, which we can say what concurrent hash map is a thread safe object. What it concurrent hash map is a thread safe object. Got my point, right? So I want to add these statements, okay? I want to add these statements. Then after that, I will, talk about what is fail-fast iterator, what is fail-safe iterator. I will start working on that. So let me add the statements here, guys. I want to open the document. And if you look at the methods of concurrent hash map, let's say, for example, java.util.concurrent hash map. Concurrent hash map. Okay, let's say, for example, concurrent hash map. If you look at the methods of concurrent hash map. Okay, if you look at the methods of concurrent hash map, same initial capacity 16, load factor is 0.75. So if you create a constructor, if you use this constructor for creating object of concurrent hash map, it creates a new empty map with the default initial table size 16. Same now? Correct. And whatever the difference is there between hash map and hash table, the same difference is there between concurrent hash map and hash table. But the thing is, hash table is thread safe, concurrent hash map also thread safe. Concurrent hash map and hash table both are thread safe, but in hash table, what happens? Entire object is locked. But whereas in concurrent hash map, we have a bucket level locking. That's what the difference. These things you need to bit carefully observe, remaining all same. And same methods are there. Clear method is there. Contains key, contains value. Then you have something called as entry set. All methods no need to learn. For each method, we'll understand in Java 8. I'll talk about get is there, get of key, get put is empty, key set, okay, values, okay, entry set. Got it. So put if absent. Okay, these are all Java 8 methods, reduce and all. So these many methods you no need to learn. Okay, remove is a method that you know. Replace is a method. You can replace the value for the given key. If already the key exists, okay, if currently mapped to some value, then we can replace it with the new value. Otherwise, we can store the value. That's what replace. Even put method also will do the same thing. Okay, size method is there. Values method is there. So no need of discussing unnecessarily any other method, especially. But if you want to test really concurrent hash map is thread safe and it is allowing multiple threads to perform the operation at a time or not, that we need to discuss with the threads concept. But presently only we can understand, okay, we can only understand that, okay, concurrent hash map allows threads like this. That's how I am explaining that you need to understand as of now. So let me add some statements. I will go to the collections document. In this threads only, I'll explain about what is fail fast iterator and what is fail safe iterator. Okay. So we are going to look at about what is fail fast, what is fail safe, those kind of things also I will explain. Okay. Let's first go ahead with the statements on concurrent hash map. Okay. Right. We discussed about this is the hierarchy. Concurrent hash map is a class. Concurrent hash map class implements what concurrent map. Concurrent map interface extends what map interface. Clear? Let's go ahead. Okay, yes, let's move. what I'm saying here, guys, point to write is, what's the point I want to write here? We want to write a statement with the concurrent hash map, right? First point is concurrent hash map. Concurrent hash map is a thread safe object. Okay, concurrent hash map is a thread safe object, guys. Got it? Concurrent hash map is a thread safe object. But hash map is not a thread safe object. How it is thread safe object? Okay, I'll tell you. Same concurrent hash map also contains what default capacity 16, load factor is 0.75. Map, each map will contain same thing except a hash table. Hash table default initial capacity is what 11, but this is 16. Now, how does concurrent hash map is a thread safe object? So concurrent hash map, okay, allows multiple threads to perform operation on the concurrent hash map object. Multiple threads to allow to perform update operation at a time simultaneously. But if two threads are trying to perform or trying to update the value of the same key, then the thread has to wait. Otherwise, no need to wait because of bucket level locking. So concurrent hash map applies, better word, applies bucket level locking. Okay. If what I can say, if let's say, for example, just a minute, 1 second. Okay, guys. Concurrent map applies bucket level locking. Okay. If the capacity, if the capacity of concurrent hash map is 16, if capacity of concurrent hash map is 16, then obviously how many locks are created? Obviously 16 locks are created, right? So if the capacity of concurrent hash map is 16, then 16 buckets, right? So 16 bucket level locks are created. Bucket level locks are created. How many? 16 buckets, 16 locks are created, guys. Next, what happens now? How many threads are allowed at a time to perform update operation in concurrent hash map is 16. So the max, the max number of threads right? The max number of threads allowed to perform update operation. The max number of threads allowed to perform update operation. Is 16. Okay. What happens now? 16 threads allowed to perform update operation at a time on different keys. Allowed to perform update operation on different keys is 16 better. Got my point? Got my point? On different keys is 16. So what in case if, for example, okay, if two threads are trying to perform operation, if two threads are trying to perform, right, update operation, or if are trying to perform update or modify better, perform modification of the same key, modification on the same key, then yes, I'm going to share my screen now. Just a minute. Okay, now what I'm saying here, guys, what I'm saying now, if two threads are trying to perform modification on the same key, then one thread has to wait. If two threads are trying to perform modification on the same key, then one thread has to wait while other thread is performing operation or update operation. Okay, so that's how concurrent hash map works. Okay. If two threads are trying to perform modification on the same key, then one thread has to wait while other thread is performing the update operation. Am I clear with you? That's how concurrent hash map works and remaining as it is. So, are you making concurrent hash map object a thread safe? Answer is no. By default, concurrent hash map object is a thread safe object. What about hash map? Hash map is not a thread safe object. If you make hash map object as thread safe, the entire object is logged. Okay, that's a difference. That is what I have explained you. So I would like to write those points also as well. Okay. If you make hash map object as thread safe, now what happens if you make hash map object as thread safe? Then entire hash map object is what, guys? Locked. Then entire hash map object is locked. If you make hash map object as thread safe, then entire hash map object is locked. Right? So a thread who wants to modify the value of a different key. Okay, who wants to modify the value of a different key? So a thread who wants to modify the value of a different key also also has to wait while other thread is working on hash map object, while other thread is working on it, working on the hash map object. Am I clear with you? That's how it works. While the other thread working on the hash map object. That's all the difference between hash map and concurrent hash map lies. Next. Just in place of hash map, use concurrent hash map. Currently, we don't know about multiple threads. Concurrent hash map in our threads program. Because currently these are all depends on threads concept. That's why we can't discuss it currently now. Yeah. Now let's go ahead. Yes. Guys, just give me 1 minute. Actually, there is a network issue. It's frequently getting disconnected. Just give me a minute. I'll come back and yeah, yes. Now, okay. We will understand about concurrent hash map example in threads concept. Okay. So let's do one thing, because if you want to check if you want to check whether hash map object is thread safe or not, concurrent hash map object is thread safe or not. If I want to give clarity on this, first of all, we should know about how to create the threads. And if I want to explain about what is fail fast iterator, what is fail safe iterator, all these things, first of all, we should know about concept called threads. That's why now I want to start with the concept called as multi-threading. First, understand about what is process, what is thread, and what is the meaning of context switch. How can you differentiate a process and a thread, and how to create a threads in Java? Okay, these are all the things. First, I would like to explain you now. First, I want to explain you now all these points. Once you got to know about how multiple threads can be created, while discussing about multiple threads concept, we will take a concurrent hash map object. We will create two threads, and we will see whether two threads are allowed to perform the operation at the same time or not. Okay, when two threads are working on the same object, we want to check whether concurrent hash map object is allowing or not, and a hash map object is allowing or not allowing. Okay, right? So you'll understand about clarity like what hash map object, what is happening in hash map object, what is happening in concurrent hash map object, and what is fail fast iteration, what is fail safe iteration. These kind of things you will learn in the threads concept. That's why we will move on to threads now. You got the difference between all them, almost collections you got, but to show practically about concurrent hash map allows multiple threads to perform operations simultaneously on different keys. It has a bucket level logs. Okay, we are going to discuss about threads programs at that time. Now, we will like to, discuss with the concept of multi-threading. This document, I'll share it with you. We'll start with multi-threading. And finally, first we want to understand about a concept called as what is a process. In multi-threading, first thing to know is what is process. They'll discuss about what is thread. Then we'll discuss about what is the difference between a process and a thread. Okay, like this, we are going to discuss about that. So we'll start with the topic now. That's better. Any of these things I will cover with examples of concurrent hash map and what is fail fast iteration, what is fail safe iteration. I'm just going to cover all these things in the threads programs. Okay, guys. So I want to start here. I want to tell you something called as multi-threading. I want to talk about a concept called as multi-threading. We are going to start with the multi-threading topic now. Okay, yeah. Let's see how multi-threading works. Okay, I'll talk about what is the meaning of what is the concept called as multi-threading. See here, folks. The thing is, what I'm trying to say is, first you have to understand about a concept called as what is a process. First you have to understand about a concept of what is a process. Okay, let's start with that. Just give me a second. Yeah, yeah. Okay. Now let's understand about, guys, multi-threading. In this multi-threading, first we'll start with the concept called as what is process. We'll talk about a concept called as what is process first. Okay, we'll understand what is process. Actually, every program in execution or every application execution is called as a process. Every application execution is called as a process. Okay. See, observe here. I repeat once again, every application in execution is called as a process. What is the meaning of every application execution is called a process? For example, you take Java project. In real time, what happens when you build the application, a jar file is created, JAR, which is a project artifact we call. It is called jar file, JAR, jar file. Okay, guys. Jar file is created. Now, what I'm trying to say now, I repeat once again, project jar file is created first. Got it? Now, that jar file gets executed. Means we are going to execute the jar file of a Java project. What happens now? One process is created in the operating system. Nothing but what we can say in the RAM. The jar file will be loaded into RAM now. Nothing but one process created. Which means what a process created means our application execution started. That's why we are calling it as what? A process is nothing but what? A process is nothing but an application execution. A process is nothing but it is an application execution. An application in execution is called as a process. Okay. An application execution is called as a process. That process will be stored in at operating system level. This is whenever we start executing Java application, an application execution is started. That process will be stored into RAM. And in RAM, there can be multiple processes available because multiple applications we can run simultaneously in a computer. So there is a scheduler that will allocate some time for each process to execute. That time is in approximately milliseconds, like 100 milliseconds, depends on operating system. So we are not getting the difference outside. Like now this application has got the chance to execute and this application is now waiting. Okay, those things we cannot see because of the time is very, very less, like 100 milliseconds only. That too depends on operating system to operating system. But thing is, every application, for example, I have opened Zoom. Zoom is an application. Means Zoom application is running in my computer. I open browser. Browser is one application. So browser application also running in my operating system. Means both are running in RAM only. Okay. So multiple applications can run now. So application in execution is called as process. So Zoom is one process in my operating system now. And for my browser, there is a process in my operating system now. Browser has a process. Zoom has a process. Correct? They all have a process. So that's what I am also talking about, right? So what is process? Basically, process means it is an application in execution. An application in execution. A process means it is an application execution. That is called process. Right? For example, if you start the browser, browser means Google, Chrome or whatever. If you start the browser, browser is an application. So if you start the browser application, then what will be created? Then a process is created in the operating system. That is actually called as process. Okay, if you take another example, for example, if you run a Java application means basically jar file we call. So if you run a Java application, then a process is created in operating system. A process is created in the operating system. This is called as process. For every application, there is a process. For example, Zoom application you started, that is nothing but one process. Okay, right? For example, you for example started a music application. Let's say, for example, media player, otherwise say Spotify. That is an application. That is one process. For example, Skype you started. That is one process. Like that. Every application executes in the operating system. For that, a process is created for that. So if you run a Java application, then a process is created in the operating system. If you run a browser application, process created. That's what process meaning. Now, we'll understand about now thread. Our next intention is to know about what is thread. Okay. Now within a process, I mean to say that in a single application, within a process, a thread is I mean to say that a separate execution of sequence of steps or sequence of statements. So what a thread is a execution of a group of statements separately from rest of the process. So means in what way I can explain you, I'll tell you clearly about how you can understand about a process and a thread. Okay, because understanding the multi-threading is only the difficult concept. Difficult is not difficult actually, but people feel like it's a difficult one. Okay, within a process, suppose there is a process now, right? Within a process, if you want to execute a group of statements, okay, what I can say, in what way I can explain so that you can understand. That's what I'm thinking on. Okay, I will tell you. Basically, what is thread? A thread consists a group of statements which are executed independently. So better what I will use. Which are executed independently from the rest of the process. That is actually called as a thread. Okay. Let's say, for example, okay, I mean, to understand this in a better way, let's say example, we'll take it up. For example, I have created an application. For example, I created one application, let's say. This is the application. In this application, I have created some statements here. These statements are actually for uploading the students' details to the database. And the next, these statements are, let me use a different color. Now, let's say, for example, these statements are, generating the reports for the students. Okay, by collecting the details from the database. Are you getting my point, right? Okay, guys. So try to understand what the point I'm saying now. Okay, let's go ahead, guys. I'll tell you. So point is now, this is my application. First three red lines are uploading the student details. The next three black lines are for uh, generating the reports. Actually, if this application starts executing, first the student details are uploaded, then the student reports are generated. But it will take more time. It will take more time. Then what I want to do? I want to do both the tasks simultaneously. If I want to perform, this is one task, right? One independent task, like uploading the marks to the database or uploading the student details to database. The second task is generating the reports for the student details. There are two independent tasks. If, for example, after uploading all the students' details, then if I start generating the reports generated bit late. It's very late. If the two tasks are working simultaneously, then application can finish faster. Because if, for example, I'm not performing the two tasks simultaneously, then my application is just going to use one core of the CPU. Even though my CPU has multiple cores, but I'm utilizing only one core of the CPU. Right? One core of the CPU. You know, our CPU has 4-core, octa-core means 8-core. Okay, you know, we have a 8-core processor or 4-core processor. Like that, we have no CPU has multiple cores. If the entire application is executing sequentially, then we are utilizing only one core of the operating system, but we are not utilizing the maximum power of the operating system or maximum power of the CPU. So if any such kind of independent tasks are there in application, you can execute them simultaneously. If you execute the independent tasks simultaneously, then what your application can execute faster and you can utilize the more power of the CPU because multiple cores you can utilize. For example, in my case, 2 cores I can utilize. One core is for one core. In one core, one thread is working on uploading the students' details. In another core, another thread is working on generating the reports of my application. So within one application, we are creating 2 threads. One thread is for uploading the details, other thread is for generating the reports. So what is thread here? Thread is nothing but it's a group of statements. Okay, which is a group of statements which are executing independently from the rest of application. Rest of the application means what? Application execution is called as one process, means rest of the process. That's what called as thread. So guys, am I clear with, did you understood about what does it mean?
Yes, sir, understood.
Okay, that's what actually called as a thread. Okay, what about the other guys? Did you understood about what I'm trying to say? So I will add the definition of a thread, but actually this is how the thread is going to be. That example, general example use case is like, as you are listening to my class, and for example, after the entire class is over, if you start writing the notes, then you're doing what? Only one task at a time. Okay, you are one application, but you are doing task by task. But you're not executing you're not doing the 2 tasks simultaneously. Nothing but if you're simultaneously listening to my class and writing the runtime notes also, it is comes under what? Multi-threading. Because you are performing 2 tasks simultaneously, so that what within this session only you are listening to the class and writing the notes, both are completed. But otherwise, what happens? First, you are listening to the entire class. After the session is over, after the Zoom is disconnected, after end of the meeting, then if you start writing the notes, for example, then what happens now? You're doing only one task at a time. Then it's get delayed, right? The same concept here also. That's the best example use case to understand about in general how the threads looks like, how the multi-threading works. Okay. So I just want to write the definition for the thread now. So now we need to understand about what is thread. So a thread is a is a sequence of statements of an application. Okay. Sequence of statements of an application which are executed independently from the rest of the application. A thread is a sequence of statements of an application which are executed independently from the rest of the application. That's called as a thread. That's a definition of a thread. If you want to tell me the thread definition. So each thread will perform a different task. Okay. An independent task, otherwise we can say that. Okay. If an application has independent tasks. Okay, I repeat. If an application has independent tasks and okay, if an application has independent tasks and okay, guys, if an application has independent tasks and if they are executed sequentially, not simultaneously, sequentially, if they are executed sequentially one after the other. If they're executed one after the other as independent tasks, and if they are executed sequentially one after the other, then application execution will take more time or longer time. Right? Application execution will take longer time. If they're executed sequentially one after the other, then the application execution will take longer time. Okay. Because how many cores of the CPU that we are utilizing? Because only one core of the CPU is utilized. Even the CPU has multiple cores, but our application is utilizing only one core of the CPU. Only one core of the CPU. Okay. That's why our application execution will take longer time. If the tasks are created as threads or independent tasks. If independent tasks are created, okay, are created as threads. If independent tasks are created as threads, and if they are executed not sequentially, simultaneously, right? If the independent tasks are created as threads, and if they are executed simultaneously, then okay, if they are executed simultaneously, then application execution will take short time. Our application will be completed. Our application execution will be completed. Will be completed in a short time. If the independent tasks are created as threads and if they are executed simultaneously, then application execution will be completed in a short time. Okay, guys, did you understand the point now? And then application execution will be completed in a short time. That's how multi-threading works. How it is possible? Because each thread will run on a separate CPU core. So we can utilize the multiple CPU cores of the operating system. Okay, that's how the application execution is completed in a short time. So let's see. For example we'll discuss here. Example, just writing statement now. Later we'll see program, but example. Example is what? So example, suppose we have created a Java application. We have created a Java application which will upload students' details to the database, or students' details of a university to the database, and then it will prepare reports for the okay, it will prepare the reports. It will prepare the reports for the students. It will prepare the reports for the students, year-wise or whatever it is. Okay, students. It will prepare the reports or year-wise reports for the students. For example, year-wise reports for the students. For example, if this is the application, suppose, assume that. Okay. If threads are not created, in application, then okay, then the application can use only one CPU core. Application means process, right? Then the process, application execution is called a process. If the threads are not created in application, then the process is executed on a single CPU core. Is executed on a single CPU core. Correct? Execute on a single CPU core, and it will take longer time. Now, if threads are created, like one thread for performing upload task, and other thread for performing. If one thread for performing upload task and other thread is for performing, let's say, what is that? Reports. Performing reports. Then the two threads can run. Tasks means threads. The two threads can run simultaneously on two CPU cores, because our systems contains at least 4 CPU cores nowadays, minimum that is. Some systems are having 8 CPU core, octa-core processor. Okay, some CPUs are having 12 CPU cores. Okay, so like that now. So threads can run simultaneously on 2 CPU cores. So the application, the process otherwise. So the process is completed in short time. Okay, in short time. So this is actually called as multi-threading. What is multi-threading? Multi-threading means executing multiple threads in an application simultaneously. That is called multi-threading. Every Java application contains at least one thread, which is called main thread. For example, if you take entire application, you consider it is one thread. Okay, I repeat, entire application is called one thread. Na? Entire application has one thread. That is called main thread by default. By default, every Java application contains one thread. That is called main thread. Okay, if you create threads explicitly, then your application is multi-threading application. And from where you can create the threads, you can create the threads again from main thread. So a thread can be created from a parent thread only. Thread can be created from a thread only. The parent thread is main thread. Suppose from main thread, I am creating thread 1. From thread 1, I am creating thread 2. Then for thread 1, parent is main. And for thread 2, parent is thread 1. So hope you guys got the point. Okay, so the process is completed in short time. This is how called as multi-threading. Now, what I'm trying to say is now every Java application contains at least one thread, which is called as main thread. Entire Java application is one thread now. That is called main thread. So far, we discussed about all our Java programs, which are containing only one thread. That is called main thread. Guys, every Java application contains at least one thread, which is called main thread. Okay, this is the point. Okay, cool. Now we'll understand about how the threads can be. So simple thing is what each thread is going to perform one piece of application. One thread is one piece of the application. It is going to perform one task. And other thread is another piece. It is performing one more task. Like that, within application, we can create multiple tasks. We can execute them simultaneously by creating multiple threads. So when you want to execute multiple tasks of an application simultaneously, then you have to create multiple threads. Otherwise, don't create the threads. So in every application, threads are not required. If your application contains multiple tasks, and if you want to execute them simultaneously, then you need to create multiple threads. Okay, that's true. Correct? Okay, now coming to the point here, yes. Then how we can able to create the threads? Now, how to create the threads? Do remember, a thread can be created from a thread only. Normally in Java, what happens? We are going to create a thread from main thread. Okay, already main is a thread. From main, we are creating another thread. So thread is created from a thread. For example, from that thread, if I create another thread, that becomes again a thread created from other thread. A thread can be created from a thread only. That's what the point. Always keep it in mind. Okay. Good. Because main is a thread, we create generally in our examples, we are going to create the threads from main thread. Okay. Next, how do we create the threads now? So how can we create threads in Java? So how can we create threads in Java? There are two options available. In Java, there are two ways are there. One way is by extending thread class. There is a class given in Java called thread class. Second way is by implementing runnable interface. There is an interface called runnable, R capital. Runnable is a function interface which contains only one abstract method. By extending thread class or by implementing runnable interface. Two options are there. We can create threads in any way. Okay. Suppose if you want to create a thread now, you extend thread class and you have to override run method. A thread logic must be defined in a method called as run. I'll tell you why we should define that logic in run method only, because you are going to understand that in thread life cycle. After creating threads, you will understand about thread life cycle. Okay. First, I'm talking about how we can create threads in Java. There are two ways are there. One is by extending thread class. Second one is by implementing runnable interface. Okay. See, for example one I'm writing. Example I'm writing. Both I'm writing side by side. Example. See, I'm writing both side by side. For example, I'm writing here. Okay, for example, I'm writing here class my thread extends thread. Class my thread extends thread. Thread is a class in Java. So I'm extending class to class is extends keyword. And which method I need to override? I need to override a method called as run. Override public void run method. Override public void run method. I'll tell you why we should override run method only. And here you can define the logic of the thread. The task or logic or whatever logic of the thread. Okay. Logic of the thread. Okay, guys. Logic of the thread. This is one way of creating thread. The other way of creating thread is we can do like this. That is one way. Other way, class my thread implements runnable. Here also we should override the same run method only. Public void run. And here logic of the thread. Okay, guys. This is one example. This is the other example. Okay. Class my thread extends thread. Class my thread implements runnable. The two ways now. But in both the cases, you should override the same method, which is called run method. Actually, thread class also implements runnable interface. Thread is a class now. This class also implements runnable interface. In thread class also run method is overridden. But again, when we are extending thread class, we also need to override run method only, because when the thread is in running state, run method is called by the thread scheduler. That's why we need to override run method only. I'll tell you at the time of thread life cycle, you'll understand all these things. But these are the two ways of creating thread. One is by extending thread class and second one is by implementing. Okay, one is by extending thread class and second one is by implementing runnable interface. Two ways of creating thread. Okay. You have to understand which is a better way. Just a minute. Okay, I guess. There is one way is extending thread class. Second one is by implementing runnable interface. Are you clear, guys? Okay. One is by extending thread class, and second one is by implementing runnable. Two ways are there. We'll discuss about which is the better way, but there are two ways now. We have to override run method only in both the ways now. Okay, right? Next, this thread can perform one task, this thread can perform other task. You can create two different threads in one application, and we'll see how we can able to start writing the programs on the multiple threads. Okay, cool. I just want to open the IDE. Actually, implementing runnable is considered as a better way than extending thread class. You will understand about these things. I'll tell you, but just let me check. First of all, I think I have a code for thread demo. Yeah. See here, guys. Okay. Just a minute. Just I have created in both the threads I have created just by using extends thread only. But actually, other way is by implementing runnable also. I will tell you. I will show you that example as well. If you look at this example, the first thread I am just creating to the task is here. It has to print numbers from 1 to 10. And I will give some sleep method because, each thread will get approximately 100 milliseconds on CPU core for execution. Okay. Approximately, it will see 100 milliseconds of CPU time is allocated for each thread, approximately. That depends on operating system. But actually, to print 1 to 10, 100 milliseconds is more time actually in operating system. It is going to complete just in a 1 millisecond approximately, or even less than 1 millisecond. If, for example, this task is completed within a less than of 1 millisecond, then I cannot show you that two threads are executing simultaneously. Correct? I can't show that the two threads are executing simultaneously because I have to show you now this is called multi-threading, where two threads are two tasks we can do simultaneously within application. Correct? That's why I'm giving a sleep time of 2000 milliseconds. 2000 milliseconds, I mean 2 seconds. If I say sleep of 2000 milliseconds, this thread will wait, or this thread will enter into waiting state for at least 2 seconds. In this meantime, this thread will get the chance to execute. Again, when this thread goes to sleep, that is waiting, then other thread will get the chance to execute. We can able to see that the two threads are executing simultaneously to show you that actually we are getting sleep time. If you don't provide any sleep time, then each thread will have 100 milliseconds. Okay, 100 milliseconds of time is allocated of CPU for execution. But to perform this task, 100 milliseconds is very high time. If that is a very big task, okay, it is not enough. But for our task like printing 1 to 10 or 11 to 20, 100 milliseconds is not required. So we will not get a feeling like the two threads are executing simultaneously. So to get that feeling, we are forcefully telling that thread that you go to sleep for 2 seconds. You just print one number, then immediately go to sleep for 2 seconds. Because in this meantime, we can able to see the other thread also executing on the CPU core, other CPU core. And, we can able to see that the other thread also performing, nothing but the two threads are executing parallelly. And the sleep method throws interrupted exception, which is a checked exception. That's why we are keeping the code in try and catch blocks. And exception handling. So what is this method and all, But here, both the threads are created by extending thread class only. I will also show you by implementing runnable next. Okay, and we have to override run method only. You will understand in thread lifecycle what I'm going to explain you next. And once the threads are created, this is the main thread. Public static void main is the main thread. I told thread can be created from thread only. Here classes created, but how do you create objects for them? Here you are creating objects. Once a thread object is created, you need to call start method. You will understand about thread methods next. Thread lifecycle, I'm going to explain you. That's the next topic we are going to see. T1 dot start, T2 dot start. Nothing but two threads we are starting from the main thread. Okay, so if I run this program, you can able to see that the two tasks are, one task is print 1 to 10. Other task is print 11 to 20. I want to do the same, the two tasks simultaneously. In my application, both are independent and I want to display the I value, J value simultaneously, not after the other, one after the other. That's why I'm creating two threads. Because I want to execute the two tasks of my one application simultaneously, not one after the other sequentially, not the sequential, simultaneously. That's where we are working with the concept of multi-threading. Okay, let's run this program. I'll give you more applications tomorrow, but you can see now. I'm parallelly, the two tasks are executing. I, J, both are executing simultaneously. You may not be getting exactly same order, but definitely I and J both you can able to see. It's not like first I value, then J value. First, not all the I values, not all the J values. Both I value, J value, both are printed. Nothing but the two tasks are executing simultaneously. This concept is called as multi-threading. How do you create a thread in Java? One way is extending thread class. Another way is by implementing runnable interface that we'll discuss next, but currently we are only working with extending thread class. Tomorrow I'll show you about implementing runnable interface also, and also what is the thread life cycle. All those things I'll cover you tomorrow. Okay, guys, that's the session for today. We'll continue on tomorrow. Okay, I will share all the notes. You don't worry. The example, this example also for practice and all. I will share all these notes. You please go through that. For threads, I'm going to share a separate document. Like collections document is over. Now next, I'm going to show you a separate document for threads. I'll create a new document for threads, and I will copy the today's whatever the statements I've written, and also this example code. In this example, both are extending thread class. In tomorrow's example, I will also talk extending thread, implementing runnable. You can find the difference, and we'll also discuss about which one is the best way, whether extending thread class is the best way or implementing runnable interface is the best way. That we are going to discuss about it in the tomorrow's class. And we also see what is the thread life cycle. Okay, what are the different life cycle states or stages of thread life cycle. We are going to look at about life cycle. That's also important one to know, everybody. Then we'll see how can you differentiate a process and a thread. Meanwhile, you also try to find out, guys. Please go through this. Please dig into this topic and try to find out what is the difference between a process and a thread. Okay. Please try to find out difference between a process and a thread in the meantime. Today, you dig it. Try to find out the difference between process and thread. Please try to understand the difference between a process and a thread. Tomorrow, I'll ask you the question. Okay. That's for today, guys. And we'll continue tomorrow.
Sir, I have a question.
Sure. Make it faster.
Like, is it any way to find how many processes are going on in our system, like threads or process?
You can able to see how many CPU cores are available or how many processors. Processor means CPU cores only. There is a class called as runtime in Java. I'm writing the statement. Please try to execute the same statement in a Java program. Runtime dot get runtime dot available processors. This is the method. Execute the same statement as it is in a Java program and check it.
Okay, sir.
Okay. Yeah.
Thank you, sir.
Yeah. Thank you, guys. Okay, we will continue on. We'll continue tomorrow. Thank you.